Alright, so let's watch this video. Pay attention. So I want to comment on that. This is true. He when he was working on the periodic table, some elements hadn't been discovered yet, and when he was working on it, he actually figured out and calculated all the properties of the missing elements. And some French guy came along and said, "I discovered this new element." He really did send a strongly worded letter saying, "You're wrong. I discovered it. I theorized it in my mind. I knew it as it." And he looked at this guy's results and he says, "You're wrong. I don't care if the fact that you found it, and measured this data. I know with 100% certainty, without ever looking at that chemical, what that chemical is like." That's how strong his periodic table was. He was able to know all the properties of something he's never seen or anyone before him has ever seen. Cody, keep your mask on. This way of cutting the periodic table and wrapping it around is probably the most accurate way of representing the periodic table. The rows form and loop around each other. So this is how the periodic table should look. However, if you were to try to make it that size and print it off on a piece of paper, you wouldn't be able to read anything. It would be too small. So what we usually do is we take those two rows in the middle and we break them off and put them down below. But technically, the periodic table should look like this. We'll watch another one? No, we'll go over it. No. So I'm going to pull up Mendeleev's periodic table. You'll notice some differences between his table and the current one. Yes. So here is his periodic table. It's super blurry. I can't find a good image of it. So compare it with the real one. So notice how it's organized. It's organized flipped around. We do his groups are rows, and his periods are columns. That's the opposite of how we have it. So if you look at the first group, that's hydrogen, lithium, potassium. It goes lithium, potassium. So on the real periodic table, it goes down. On his, it goes to the right. Lithium, sodium, potassium, rubidium, calcium, and so forth. And that's not calcium, that's cesium. So it goes to the right. Hydrogen seemed different than the first group. That's the reason why it's separated by itself. If you look at fluorine, chlorine, bromine, and so forth, oxygen and sulfur. So it's flipped around. Also, his table is sorted by atomic mass, not atomic number. So some key differences you should know. Mendeleev's table was arranged by atomic mass. And he put groups in rows and periods in columns. The modern table is arranged by atomic number, or number of protons, and groups are columns, and periods are rows. If you were to organize his table closer to looking like our modern table, it would look more like this. So here's a modernized version of his table, where we flip it around so that these, again, hydrogen was all by itself. You can move it anywhere. And we get these groups. And he was able to see gaps in his table. He put question marks and he predicted the mass of those elements. He was very accurate in his predictions of their mass, and their properties. You'll notice he put the transition metals all the way on the right side, and not in between beryllium and boron. So, let's look at the periodic table. What is this group called, excluding the first element? So this is the alkali metals. And what is this one called? The alkaline earth metals. And what about this whole block? Guys, y'all lift y'all's heads up off y'all's desk. Michael, Thomas, put your mask on. What goes inside? Oh, those are the transition. Transition metals. What about this group? This starts with B. That's the boron group. Yeah, that's the staircase. And fluorine, oxygen, nitrogen, and what goes in between? Carbon. So what is this group? This is the carbon group. Nitrogen group. So this is the oxygen group. Nope. What is this one called? Halogens. And then what's this one? Noble gases. And then these right here, I'll draw it super tiny. These are the rare earth elements. Rare earth metals. Another name for rare earth is called the inner transition metals. Be quick. Be quick. Yes. So, what does everything in group 1 have in common? No, not atom. No. So, remember that, so an atom looks like this. An atom has a bunch of protons and neutrons in it. And then it has these orbits. And we call this energy level 1, we use the letter N, energy level 2, and energy level 3. So these are energy levels. Also known as shells. And this last one, last energy level, is called the valence shell, or valence energy level. They all have one valence electron. So, alkali metals have one valence electron. No, they all have different. But different numbers of energy levels. So what does... So the alkaline earth metals all have what in common? They all have two valence. Yes, so alkaline earth metals have two valence electrons. And boron has 3. And so forth and so forth. Noble gases have 8. I have a question. Yes. What's hydrogen? Hydrogen also has 1. So alkaline earth metals and hydrogen. But hydrogen only has 1. It only has 1 electron, so it only has 1 electron on the outer orbit. So, what did we react with? So we'll go into that much later in the year. But anything that wants only 1 electron, it will react with it. So hydrogen. So here's an important thing. The first energy level can only hold 2 electrons. So if we have only 1 electron here, it wants to make this shell full or complete. We complete the first energy level by having 2. So if we take another hydrogen atom and put it next to it, its electron will be shared with this other hydrogen. This is the reason why hydrogen gas is H2. If we look at oxygen has 2, let me darken this so that you can tell that this is an O and not the energy level. Has 2. On the outer side, there has 6. So 1, 2, 3, 4, 5, 6. And if I draw another one, so if I draw, it's hard to draw. So what we see is the 2 electrons from here and here will be close to this deal, and the 2 electrons from this one will be close to here. And then we have 6 that go on the side. 1, 2, 3, 4, 5, 6. So we count how many electrons are around on the outer one. We have 1, 2, 3, 4, 5, 6. I did this wrong. So if we put one of the electrons here, so 1, 2, 3, 4, 5, 6, 7, 8. And then 1, 2. It's kind of hard to draw it like this. What we end up having is that occasionally these 2 electrons are shared between the 2 oxygen. So oxygen has 6 valence electrons. I'm not drawing the picture right. It has 6 valence electrons. And another oxygen has 6 valence electrons. So what they do is they share 2 pairs of electrons with each other to make them have 8. So oxygen 2, if we draw it out using a form, we put it as a double bond. Put your phone up. Or mute it. Mute your watch. I didn't see a phone in your hand, so I was like wondering. I'm like, where's it at? So when I draw the periodic table, where are all the metals? So these are called transition metals. These are called the alkaline earth metals. Excluding hydrogen, these are called alkali metals. These are called the rare earth metals. And then we have this staircase going down. And so we have metalloids somewhere in here. And then we have the nonmetals. So these would be nonmetals. So I told you that the alkaline metals, so this is group 1, alkali metals. Why do I put hydrogen with them? It's not, why I put them in the same group as them? Why? These are the alkaline metals. Why do I put hydrogen in the same group with them? Does hydrogen react like potassium? Is hydrogen a metal? So it doesn't look anything like sodium or potassium or lithium. So why did I put it in the same one? Mm-mm. What does everything in the same column or group have in common? Because hydrogen has one valence electron. Alright, there's one other thing I should get. So let me redraw this. Or let me get up here. There are two naming schemes. So we can call this group 1, group 2, group 3, group 4, group 5, group 6. $18. This is one numbering system. It's important that you know the other. We can break this up into two groups. We have A group and B group. B group is the transition metals. And inner transition metals, which is the rare earths. And A group is the rest. This one is called 1A. This one is called 2A. What group number would this be? 3A. 4A. 5A. 6A. 7A. And 8A. No, we're lucky. It's very easy to know. If I say group, what is the group name? Group A name for group 16. You just remove the 1 and we get 6A. You need to have this numbering system memorized. I won't mention the B group because this numbering system is wrong or rearranged differently. But I will often ask questions like, how many energy levels is or does the atom in 4A period 3 have? So 4A tells us it's this group, and we can number the periods as 1, 2, 3, 4. So looking at 3 going across, we're talking about this one right here. Everything in period 3 has 3 energy levels. And if I say about valence electrons, everything in 4A has 4 valence. What is iodine a group? Or what group is iodine in? Those in 7A. It's in group 17. And what's another name for the group? Halogens. What is the name of the group that has 2 valence electrons? Alkaline earth metals. And what type would they be? Metal, non-metal, or metalloid? And the alkaline. Yes. All right. Selenium. Is it solid, liquid, or gas? Is it solid, liquid, or gas at room temperature? That can't be neither. So solid. Selenium isn't. No. Yeah. What about bromine? Is it solid, liquid, or gas? Liquid. So the only 2 liquids on the periodic table is bromine and mercury. Why is mercury 15? Basically, if it was an element that was known back in Latin times, then that's the name that carried through the centuries. For example, we knew what copper was because of the Bronze Age. Silver and gold were both traded as money. Mercury was known as it was the only metal that would liquefy. Iron swords was known. So the most important metals were at least yes. No, that's Minecraft. What? Oh, you mean like okay. So, what's a semiconductor? What's a semiconductor? Good, but they're usually what type of element? Metalloid. Metals are good conductors. Non-metals are not good. So if you're in between, if you're semi, then that means you're the metalloids. Which is more reactive? Oxygen or fluorine?
Oxygen.
Fluorine is the most reactive element on the periodic table.
I think
Oxygen is very reactive, but not as much as fluorine.
Oxygen is very reactive. They make nukes. No, they might need by the spinning atom.
That's not reactivity. That's nuclear chemistry.
I have one question about money. I need to be stabbed. What time is it, boys? I wouldn't do that. I'm just gonna ask.
How many protons does lithium have?
Lithium? What's lithium at? Oh, it has one.
Nope.
3.
3. I don't know if I have. I know I have a Kahoot I did last year.
I was trying to learn, and she was like, we're acting when you
What period is iodine in?
Iodine.
What period is iodine in?
7A.
What period is iodine in? Put your mask on, Thomas. 5. Period 5. So this is period 1. That's 2. That's 3. That's 4. That's 5. Remember, these are groups. This is the group or family number. Group is a column. Period is a row. I should give a test where I give y'all a blank periodic table. But here's the deal: y'all can make over 100. For every element is worth 1 point. The symbols have to be accurate.
I would take Hey,
Put y'all's mask on. Michael.
He's fixing my mask. Kind of bloated. Simple fix.
Go get another one. I guess that's it for the day.